Hello, guys. A bit late in starting there, but welcome. Thanks for joining us. Hope everyone is safe and well. Welcome back to another season of Code and Create, brought to you by Orbis Connect. Today, really excited for this. Joined by Ben Kadel, senior Android engineer at the Very Group. I'm just going to try and get Ben up on screen here. Bear with me. Here he is. All right, I'm just trying to get us both up. 1 second, Ben.
Yeah. Hello.
Here we go. How are you?
I'm good, mate. How are you?
Very good, thank you. It's slightly sunny here, just outside the London. Whereabouts are you?
I'm in Chester, and it's gorgeous here. We should be doing this outside, so I can sunbathe at the same time.
Yeah, do you know what? If my Wi-Fi would let me, then I'd definitely be outside at the moment. Yeah, thanks for joining us, Ben. We're going to be discussing a few points to cover. We've got today throughout the presentation. Ben's put together some lovely slides that we're going to be sort of referencing throughout over the next hour or so. We're going to be discussing Kotlin, an overview of Kotlin. So anyone that's sort of new to it or has used it before, using or migrating from Java over to Kotlin, this is going to be really useful, really interesting. Some of you may have seen Ben from his YouTube channel, so he's no stranger to the camera. It's really funny and informative as well at the same time. So I'm sure, yeah, quick plug there for you, Ben. No worries at all. So yeah, we've got, if you're watching on Crowdcast, there's a few polls set up below, so do get involved on that. Vote. It's always good to see how many people have actually used Kotlin before, and if you've done the migration as well, which is something that Ben's going to be speaking about. Let us know where you're tuning in from as well, using the comments bar, or if you're on LinkedIn Live, stick it in the comments. Let us know where you are. Always good to see. So we've got Essex and Manchester or Chester at the moment.
Chester,
so yeah, Chester. Okay. So yeah, let's see where everyone is. So yeah, I guess let's get straight into it then, Ben. Give us a quick background on yourself.
Absolutely, yeah. So my name is Ben Kadel. I'm currently a senior Android developer at the Very Group. So we make the very.co.uk and Littlewood's websites and app. And me specifically, I'm an Android developer working on those native apps as well.
Nice. Okay, cool. How's everything going working from home?
It's actually all right. Yeah, it's quite an easy transition. I guess I'm very, very lucky in the fact that, you know, technology is the state it is now, that it is so seamless to just switch to working from home. It's exactly the same. Took a couple of test devices home. Yeah, just coding along as usual. It's quite nice.
Yeah, I guess, you know, for people in this industry, it's not, I guess it's sort of business as usual, really. So yeah, easy transition. Cool. So let's get straight into it then, Ben. Kotlin, give us an overview what Kotlin is.
Absolutely. Should I pop up a slide just to give it a little bit of extra flavor?
Yeah, why not? Let's get the slide involved. Yeah.
Is it something that I need to do on there?
Yeah, if you just share your screen, I'll bring it up.
Sorry.
That's all right.
Can you see the
slides. Live coding?
Excellent. Right, so ladies and gentlemen, Kotlin is the topic of the day. Let's get straight into it. Kotlin obviously is a programming language like Java, C++. Here's some words that I've collected from the internet. I'm going to just sort of talk through it, and then I'll sort of give you a bit more of a high-level overview. It's a general purpose, free, and open-sourced, statically typed programming language. We're going to cover what that means a little bit later. It was initially created for the JVM, so for the Java virtual machine that the Java code also runs on top of. And of course, for Android, it's now the primary programming language sort of promoted by Google for Android development. It combines object-oriented and functional programming, and it's focused on interoperability, safety, clarity, and tooling support. It aims to be concise and pragmatic and blah, 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 blah. All of these words are fantastic, but let me boil it down to one easy sentence. Kotlin is the new, sexy, awesome Java. Kotlin is the new Java alternative. It's as easy as that. And these words that I've put up, obviously, they are sort of like the punchlines that you see all over the internet. I've highlighted a couple of keywords that are sort of yellow or orange and underlined. And I'm going to, as we go through this session, hopefully we'll have some time to expose each of these words and sort of really prove it, really prove that Kotlin is that thing. And hopefully by the end of it, sort of show you that like Kotlin is, is awesome and greater than Java as well. And if any folks are Java developers in the audience, then I'm going to show you a little bit about how you can really easily migrate. It's sort of like hysterically easy to migrate. Just on that one then, like sort of talking about Java, I want to talk about the JVM word that I just put in there. So the JVM, the Java Virtual Machine, the thing that lets Java run code is also the same thing that lets Kotlin run code. And here's a fun little tidbit. Java and Kotlin, they both actually compile down to the exact same bytecode, okay? The JVM uses this bytecode to actually run the code, run the program. They both compile down to the same bytecode, the same .class files, and the JVM doesn't care whether it got a Java code base or a Kotlin code base. It just gets this intermediary, this .class file, this bytecode, and it can run it. And that's the absolute power of it. And if you can see these slides here, in the top left, I've got a Java example, and in the top right, a Kotlin example. And beneath them, I have their compiled .class files, their bytecode files, if you like, and sort of showing them. Obviously, they're not both the exact same bytecode, but they are the same, bytecode. They come with the same bytecode family. And just a couple of highlighting bits just to sort of prove that, like it says, line number 5 for whatever, LDC test, invoke virtual. It's the same bytecode that they both compile down to, and that is incredibly important. However, there's one massive difference, but there's many differences that we'll cover in the session. But there's one of the big differences is in the visual appearance. And here on the left, I have a Java class, person.java, whatever, that creates, it's got some variables, it's got a constructor, it's got a getter and a setter. And over on the right, I have the Kotlin alternative that does exactly the same thing as this massive block of Java code. So hopefully you can spot the difference. This single line of Kotlin code does exactly the same thing as this Java code over here. It's concise, it's clear, and it removes all of the boilerplate that specifically Java developers will know and either love or hate. And just sort of boil it down to a lot more clarity and conciseness. And hopefully in this session, I'm going to show you that like Kotlin could knock out Java easy peasy. That's a good analogy, right, I suppose.
Yeah, that's mad seeing the difference there between the amount of Java code to the Kotlin code. It's incredible. So I guess just to go back on your first point, so Kotlin is purely used for Android.
Not purely used for Android. No. It's a general purpose. It can be used all over the place. Right. All over the place. In fact, I've got another little slide. If that. Yeah,
go for it. Another slide.
Where it can be used. It's not just in Android. Obviously, Android is one of the sort of the big places because Google came along and said, hey, this is the language that we prefer. This is a language that we recommend you use. But it can be used in a bunch of different places. And here I took this actually from the Kotlin Lang website at the top. That's the actual website for the Kotlin language. And I've just highlighted a couple of bits, and I'll just sort of tell you where Kotlin can be used. Obviously, in the bottom right, we've talked about Android already, so I'll skip past that. Bottom middle here, this blue circle, web development, like website development, right? It's kind of weird. You can write Kotlin code, and then it can transpile through some magic nonsense behind the scenes. It can transpile into JavaScript code and front-end web devy code, which is mad to me. It's incredible. So there's the front-end side of things. And then just one to the left, this sort of yellow circle, the server side, Kotlin can actually write like server-side applications. For example, in Java, we have like Spring or Spring Boot, whatever it's called. In the Kotlin world, there's just one example I've just plucked out there, Ktor, which is sort of the alternative in Kotlin, which just lets you do like the HTTP requests and all that kind of stuff. So you can write front-end and back-end stuff with Kotlin. Top middle native, right? This one's absolutely mad. I said the Kotlin runs on top of the JVM, right? But you can actually use something called Kotlin native to compile Kotlin down to native binaries, which is absolutely mad. It's absolutely crazy. So front end, back end, native stuff. And then this one in the top left, I didn't know about this until I started sort of like digging in to the content for this talk. Mobile cross-platform. So you can essentially write one common Kotlin code base and have it compile or build down to things that iPhone apps need, and also things that Android apps need. So you can have like a single Kotlin code base that builds for iPhones and for Android devices as well, which is mad. Obviously, I'm sort of very much high leveling that, but that's the idea, yeah. So Kotlin obviously can be used absolutely anywhere. The short, quick punchline is that Kotlin can obviously be used in all of these wonderful places, but Kotlin can also be used anywhere that you use Java, and can be replaced, and can replace Java as well. So yeah.
Cool. Yeah, I mean, you mentioned it a few times actually about Google. I think it was around this time last year that it announced that Kotlin's its preferred language for their Android development. How much of an impact do you think that that's had in Kotlin's popularity? Obviously, I guess any language really, when a massive tech company, like Google comes out with something like that, obviously that must boost the profile massively and make it become a lot more popular, I guess, within the dev world.
Yeah, absolutely. It's skyrocketed Kotlin, to be honest.
Yeah.
And from my point of view, specifically, I didn't even know the language existed until Google I/O, till they sort of announced it, and it's absolutely mad. And the fact that Google are saying it's their preferred language means that all of their lovely code examples and their code labs that help you learn specifically Android development, they're all in Kotlin. So, it's really important. And yeah, just in terms of, code bases, historically, Android development was, Java. You wrote apps in Java. I think you can even write apps in C++, but let's not go down that route. And now it's completely transitioned. Like the majority of apps, hopefully, are now mostly Kotlin. And if not, Kotlin and Java work interoperably. It's something I'm going to cover on a little bit later, but they work together in unison beautifully. One can call the other and vice versa. So to have like a phased switchover in your app from some Java to some Kotlin works absolutely fine.
Yeah. So, I mean, you touched on it earlier when you showed the differences between the amount of code between Java and Kotlin. But aside from that, what are the other sort of obvious differences with Java and Kotlin?
Cool. Yeah. So I've got another little slide here. I've got lots of lovely content for people to see. So this is just a really quick table that I threw together. This is what I'm calling these sort of obvious differences, like the visual differences, I suppose. When somebody picks up a Kotlin file and looks at it for the first time, they'll go, oh, wow, these are different. So I've created this really simple table here to help with just some of it. Again, just scraping the surface. Left column is Java, right column is Kotlin. For example, Java files in the top have .java files, right? And Kotlin is .kt files. In Java, there is the semicolon at the end of every line, the famous semicolon that always seems to go missing. In Kotlin, the semicolon is optional, which basically translates into don't use the semicolon in Kotlin unless you're some sort of crazy masochist.
So you don't need it at all. You don't need it
at all.
No,
you don't need it. It's completely optional. So you shouldn't waste your time with it. Java has statics. Kotlin has companion objects. Java uses the new keyword to instantiate new objects. Kotlin doesn't use that. The way that functions are declared in Java and Kotlin is different. Java has string concatenation, which is where you put a string and a plus and then sort of the variable that you're trying to print out. Whereas in Kotlin, you can just whack that variable right inside of the string, throw $1 on the front of it, $sign, and Kotlin will go, oh, you want me to actually like read this variable? That's fine. In Java, variable types come before the name of the variable. And in Kotlin, it's the variable type comes after the name of the variable. So there's just a couple of differences. I won't drag on too much about that, but there's just a couple of things to sort of spot before we see some code. And do you want me to? I can show you some code now, and we can sort of just get immediately immersed in some Kotlin code and see what it looks like.
Yeah, that'd be good to see for sure. Yeah, 100%.
So here is something that I prepared earlier. Here is some Kotlin code. Okay, first of all, I want to just say to people, please don't be worried if this makes no sense to you. We're sort of going to go through this session and start to understand some things. It's not going to be a teach you how to code Kotlin from scratch thing. It's more going to be show you the code, explain some of the features, show you why it's awesome, etc. Here's
sorry. Just are you able to zoom in on that? It's just a bit blurry at the moment. If you could try and zoom in a little bit, we might be able to see that a bit better.
So can you see that? This one on the right is blurry. That's purposefully blurred out.
Oh right, okay. Well,
was that the one? Or
Well, I mean, it's definitely helped on the left side, but I did think the right one was very blurry. So
Yeah, that's blurred
ignore
on
me.
purpose. That's fine. So just for reference, this right bit is the output of this code when it runs. So I've just left this optional. I didn't want to show people straight away in case they wanted to have a little guess at what this code is doing on their own. I'll show you in the next slide what it does. This is some code that I've written in IntelliJ, which is an IDE for Java and Kotlin. It's absolutely brilliant. It's made by JetBrains. And this code doesn't do anything really, in particularly special. It's just some nonsense code thrown together. We can start to see some similarities to Java, some hopefully relatively obvious ones. Println, println is the system.out.println in Java. Print this text to the screen. Here we've got Steve age, which is me just creating a variable and giving it some value. Steve age is 30, blah, blah, blah. Here, this p1 equals person. This is me creating a new instance of the person class. So you notice in Java that would have the new keyword there. Here we've just got the person, and below is the actual class definition. Again, don't worry if none of this makes sense. We'll get through it slowly and gently, just sort of pointing out some of the obvious things. We've got collections and lists. So like mutable list of is like the array list, and so on. I'm going to flick to the next slide, which will reveal the answer to the code running as well, just in case anyone was taking part in that, or they can sort of check their answers. There's how it actually runs this piece of code. I won't bother going through that. What I want to do is point out some of the things that are happening in the Kotlin side of the screen. Whoa, goodness, screen's going mad. There we go. So let's look at these. Each of these little red blocks I want to address. Var Steve age equals 30 is me declaring a variable called Steve age. In Java, it would be int Steve age equals 30. Notice in that line of code, we have not written the word int anywhere, right? Because Kotlin has something called type inference, where it's clever enough to go, oh, you gave me an integer, so I must be of type int. And it's type inference is incredible because it saves you you don't need to write a whole word of int or string or whatever. Type inference, it can infer the type. The next one down, vars. So in Kotlin, we have vars and we have vals, and these are like declaring the variables. Vars are mutable, meaning that they can be changed. So I set Steve age to be 30, and I immediately changed it to be 31. Vars can change, whereas vals, so vals here, cannot change. Once I set a val, it is immutable, meaning that I cannot change it. I'd get a build time error, a compile time error. We have some collections down here, like mutable list of, as I said, it's like an array list in Java, just a list that I can add to and take away from. Ranges, this is really cool. So this bit here, 1.10 is a range, and it basically translates to, in Kotlin, the numbers 1, in this case, the numbers 1 to 10, okay? So, and it's in a for loop. So what this will do, we'll just loop through the numbers 1, 2, 3, 4, all the way up to 10. Really nice and sort of concise and clear, hopefully. The it reference here, we'll talk about if references a little bit later on, hopefully. And we've, of course, got the class definition. And hopefully, if you're a Java developer, you're seeing that this class is inside of this other file. I've not changed the files because remember, we can have, from this other slide, wherever it's gone, we can have many public classes per file in the Kotlin world, whereas in Java, it's one public class per, oh, excuse me, overshot there. There we go. And also defaults, this bit here, age int is 21. So it's giving me a default parameter. So if I don't, when I'm creating a new person here, give it an age, it will default to be 21. Defaults are awesome. And then right at the bottom, this string interpolation thing that we talked about earlier, where you basically just throw the variable. So in this case, name, you throw it straight in the string, stick $1 on the front of it, and Kotlin will go, oh, you actually want me to read the contents of the variable. Nice. Yeah. So yeah, there's a little bit of Kotlin for you.
Nice. Yeah, yeah. I think everyone was able to see that. So I guess again, something that you've touched on before. Awesome features. I'll use your words. Can you give us show us the sort of awesome features around with Kotlin?
Absolutely. Yeah. So.
Just one more thing, actually. I was going to ask. Yeah. Sorry, Ben. Just on the other slide, IntelliJ that you use there. That was you said made by JetBrains, the same people that created Kotlin, wasn't it?
Keen eye, absolutely, yeah.
I've been doing my homework.
You've been doing your homework, yeah, awesome. In fact, in one of the final slides where I talk about resources, I'd give you the GitHub link to the actual Kotlin programming language, because I said it's open source. So you can go, and if you wanted to, you can look at the source code for the Kotlin, and you can contribute to it, and you can see it. And it's by the people JetBrains.
Yeah. I mean, I was gonna ask, is IntelliJ one of a few different things you can use, or is that the only one you can use with Kotlin?
One of many things you can use.
One of many. Okay.
So with Kotlin, IntelliJ is the one that I would recommend, and is the one that sort of like JetBrains recommends, and in fact, probably most of the community. It's a great IDE for Java and for Kotlin, but obviously there's Android Studio, which is more of a focus on building apps. There's Eclipse, which if you're using Eclipse, maybe consider IntelliJ as a brand new solution, but if you wanted to, there is a plugin inside of Eclipse that lets you write Kotlin and do all the Kotlin stuff. And if you're a crazy, mad person like me who uses the terminal all the time, there is a Kotlin compiler directly in the terminal, so you can write and compile code straight in the terminal without having to rely on an IDE as well. So yeah, many different ways. Okay,
cool. Yeah, sorry to interrupt you on the last one. Yeah, so let's get on to the features. I'm sure you've got a few more nice slides.
I do indeed.
Giving us the features. Here we go.
Features. So Kotlin has a ludicrous amount of features, right? And in fact, you'll hear me say this probably later, I am still learning new things every single day about Kotlin, and it's absolutely fantastic. So I just want to go through a couple of the big headline features that is sort of like a sales pitch to sort of go, yeah, Kotlin's amazing, try it out. And maybe one or two of them will make you go, oh, yeah, okay, cool, I'll give it a go just for that reason. So just bear with me, we've got a couple of slides, and we'll see how we get through. First of all, feature one, interoperability. It works beautifully with Java, okay? Kotlin code can call Java code. Java code can call Kotlin code. You can have a code base that is mixed with Kotlin and Java, and it will work beautifully. So for example, here on the left of the dotted line, I have a piece of Kotlin code, and in this code, I'm creating a new instance of the cat class. I'm terrible at coming up with the class examples, so you'll see a lot of cat, dog, animal, person. In the Kotlin code, we're creating a new cat class, and the cat class below is a Java class, right? Kotlin can call Java. On the right, we have Java code here, which is creating a new instance of the dog class. I hope you can see that. Creating a new instance of the dog class. And the dog class just below is a Kotlin class. So they can work beautifully in sync together. Sorry, my slides are, there we go. So yeah, feature one. Number two, null safety. I'm going to probably be on the slide for maybe a minute or two because this is a big one. So null safety, what do I mean by this? So the guy who apparently created the null reference called Tony Hoare, I think it is, calls the null reference his $1 billion mistake, because in applications, especially like ones in Java, it has probably cost companies thousands, millions, and billions of dollars these crashes that happen around the world because of null pointer exceptions. Essentially, when you're creating a variable and you don't actually give it a value, it's just null, and then you try and do something with that variable, it's a runtime error. It'll crash the program. It'll come to a screeching halt. So just to explain that point, there's some Java code in this gray box here, right, where I create a variable that is of type car, so it's a car class, but I set it to null. I don't set it to anything. I set it to like just, if null translates into just like empty, it's just zeros, it's nothing, nothing. And then in the next line, c.getColor, I try and get the color of the car, but I never set it. This program in Java is allowed to compile and it's allowed to run, okay? And when you run it, when it gets to this next line, it will come crashing to a halt because C is a null pointer exception. It will throw a null pointer exception. We've not established the car. And that's one thing that Java developers will be quite familiar with, these null pointer exceptions in runtime. So runtime, I'll keep referring to that, is when the program's actually going. Like when you press play on the program and it's going, that's a really dangerous time to get errors, because that's, you might have released to production some code and customers will be obviously in like runtime and they'll be experiencing the problem. Whereas in Kotlin, null safety is a huge deal, right? They still have nulls in Kotlin, it's just handled slightly differently. So we're going to go from the top right here to the bottom right to the bottom left. So in Kotlin, if I did exactly the same thing as we did with the Java, I create a new car and I just set it to null. Immediately, red squiggly line in the IDE, I cannot compile this project, I cannot run it. It is it is because of Kotlin's null safety, and that is good, okay? However, I said nulls are allowed and you can store nulls. It's just you need to tell Kotlin that this thing can be null also. And you do that by adding a little question mark, hopefully, ooh, that's visible, a little question mark after the actual type. So this is a variable called C of type car, and we add the question mark, which tells Kotlin that it can be a car or it can be null, which is fine. But then the next line, where I try and ask for that car's color, again, we have a red squiggly line, compile time error, cannot build and run, because of Kotlin's types, because of Kotlin's null safety. I cannot zoom out, there we go. Because of Kotlin's null safety. In order to access that variable, because I've told Kotlin it can be null, I have to do a little bit of extra defense to it. And we'll come down to the bottom left here to hopefully understand it. In the car class, I have a function called start car. Turn the car on, start car. And what I can do, this car has been set to nullable. It can be null if I want it to. And when I actually try and access the variable, the C variable, what I can do is add a little question mark after the variable name. So C question mark. And what that does, that's really cute. What this essentially does, C question mark, is it says, hey, C, are you null right now? If you are null right now, I'm not doing the bit to the right-hand side. So in this case, hey, C, are you null? If you're null, I'm not doing start car. However, in this example, where car is not null, we've set up the car, it's saying, hey, C, are you null right now? And so he goes, no, I've got car. Then it's like, all right, you can do the bit to the right. If that makes any sort of sense. You do all sorts of nonsense.
Yeah, it does make sense, and you deliver it quite well, I must admit.
Thanks very much. But yeah, so null safety is huge in Kotlin, and that's probably one of the things that new Kotlin developers will sort of just go, ooh, this is kind of strange. But nulls are allowed. It just protects you from that null pointer exception in a big, big way. Here's another one. Let me zoom out. Data classes. I'll try and move through this one pretty quick. Often we'll have, in like Java code bases, classes that are just made to store data. They are just made to store data. They don't do any cool, clever logic. They just hold data and give it back when asked for, getters and setters and all that kind of stuff. And maybe we even need to access like the overridable toString function, the equals function, hashcode function, all that kind of stuff. What Kotlin can do is it has this thing called data classes, where if you imagine this line of code, this bit here, without the word data on at the front, this line of code would give you the class, as we've already discovered, with its getters and setters. But if we add the word data just to the front of that, just one little word we add onto the front, then Kotlin magically derives all of these lovely functions for us, the equals, the hashcode, the toString, so that we can use them as and when, just with adding one word. That's absolutely huge. Yeah.
That must save a lot of time, I guess, as well.
It certainly does. Yeah. It certainly does. Like, what's the, why wouldn't you add 4 letters instead of, many lines of different code?
Yeah, exactly. Yeah.
When it does exactly the same thing as well. And that's one of the things that is like quite difficult to sort of grasp maybe immediately coming from Java, for my example at least, is that it does do the same thing. You sort of just have to put your trust in it. You can obviously look at the bytecode that is generated from compiling the code as well, and that'll sort of prove it to you as well. But yeah, there's a lot of sort of things that are just abstracted away from you that isn't necessary nowadays.
Yeah, so it's just essentially, it seems like it's Kotlin is like a very streamlined version of Java. Yes,
yeah, I think that's accurate to say. Very streamlined, very readable, very pragmatic. Yeah. Cool. The next one of my absolute favorites, we use this all over the place in the very group, extension functions. And I'm going to just pause on extension functions and just briefly talk about functions. So in the top left here, this is a Kotlin function. I just want to explain how they look and how they're built and how they're structured. So here is a Kotlin function that is called add 2 numbers. It takes 2 numbers and it adds them and returns out that sum number. But the signature is what I want to sort of just explain about. To create this function, we use the fun keyword. In Kotlin, we have to sort of say fun for function, then the name of the function, and then in brackets, the input parameters of the function, what's coming into the function. So here I've got 2 ints coming in. Remember in Java, it would be like int, then num1, but in Kotlin, it's flipped around. So num1, the name of the variable, and colon int. And you can think about the colon as translating into of type. So you can read this num1 of type int, if you like. And over here, num2 of type int. And then right at the end, this is the return type of the function, what's coming out of it. An int is coming back out this function. And again, we've got this colon, which you can still read as of type, but instead it's here. So you can sort of make it like this whole function line is of type int. It's sort of spitting out an int, just if that helps anyone understand it a little bit better. So now that we know a little bit about functions, just normal generic functions, let's talk about extension functions, because these are awesome. Normally in, for example, Java code, if you have a class and you want to add more functionality to it, of course, first of all, you'd consider just going in and changing the actual class definition and adding the functionality there. But what if you don't own the class? What if it's like a standard library or standard utils class, like string, for example, and you wanted to add some functionality to it? In Java, you'd have to inherit from that class, your own class, and then build on it from there, which is wasteful. And in Kotlin, what you can do is you can have an extension function. And over here, I've done 2 extension functions to the class string. I do not own the class string. I cannot physically go in and change that class. That is someone else's, but I can still add functionality to it just by doing the class that I want to extend, dot, so string dot, and then I create the function. So I've created a function that is called add dot to end, where it just takes the string here and it adds some dots. It's a bit rubbish. And the next one down is called split and spread, and this will go through the string letter by letter, adding some spaces to each letter, so it'll sort of spread the string out. Again, sort of bad examples, but the fact that you can extend any class, even if you own it, even if you don't own it, is absolutely huge. And there's at the top here, you can see me triggering those 2 functions. So extension functions are absolutely huge, and we use them all over the place in our code. So yeah, they are fantastic. You're getting a 2-for-1 in this next one. Type inference and Smartcasts. Let's split them up. The bar in the middle, I'm going to go to the left side of it and talk about type inference. We've already sort of briefly covered this, so I'll try and keep it short. But Kotlin is clever enough to figure out what type of variable it is that you're trying to make by the contents that you give it. So for example, val a is 50. Kotlin goes, 50 is an integer, so a must be an int, and so on. You know, hello is a string, so b must be a string, and so on. And a little addition I just added last minute to the slide deck here. The function return type is currently missing for main because it is type inferred. Also for function, it's inferred type that it returns unit. And just for Java developers, unit equals void. Unit equals void. Okay, just a heads up. At any point whilst you're in the IDEs, IntelliJ or Android Studio, you can hover over a variable that has been type inferred and use Control Shift and P to get this little like pop-up box telling you directly, oh my goodness, sorry, I've jumped slides here, telling you directly like this and this, what type that variable has been inferred to. So that's cool, that's nice. Bit more concise, bit less code writing. On the right, we have Smartcasts. Smartcast is a little bit confusing to explain, but just bear with me. When a variable comes in and you need to cast it, you need to change its type to be something else. Smartcasts is something that's really important in Kotlin. So what we'll do is when you have smartcast something, forever on after that point in that same code block, it will remain to be that same type. So you don't need to recast it over and over and over again. It will smartcast it for you, which is really powerful. Let me explain if that doesn't make any sense. Here is a function called take any as string, and it takes in a variable called a of type any. Any, just for everybody's reference, is like the root of the Kotlin class hierarchy. It is, for example, like the object class in Java, sort of, you know, the wildcard, top of the pecking order class. And we're taking in an any, and here we're doing 2 if checks against it. We're checking one, hey, is it a string? Is it a string type? Or is it an int type? And if a is a string, if it is of type string, then it will come into this code block, and you can see here, I've used a.length. And .length is a string thing to let me count how many letters are in that string. So here, I haven't need to recast it. I haven't need to retell Kotlin, oh yeah, a, which was any before, is actually now a string. Because it's inside of this smart cast, this smart is block here, it will just automatically do it for you. So saving, again, a lot of time. Hopefully that makes some sort of sense. Couple more. We're sort of doing multiple now per slide because we're sort of getting towards the end of the sort of big main features. When, let, and Elvis. So when, in the top left here, when blocks, nice and easy, are just replacement for switch statements. But they look far better, they're much cooler, and yeah, they're just really, really cool and powerful. when blocks replace switch statements. In the top right here, let blocks. Let blocks are really interesting. They are scoped functions. So what you can essentially do with a let block is run a bunch of lines of code against another variable or against another thing, right? Which doesn't make much sense, but let me explain it. So here in this example, I have outfit1, which is a variable, and I can do a let block, and then inside of this curly braces, I can do a bunch of things on that outfit1. And instead of calling it, outfit1 do something, outfit1 do something else, it's referred to as it inside this let block. So it's referred to itself as it, which is nice shorthand, and it's really cool. But the whole point here with these blocks is they're scoped. So inside of this curly braces block here, I can create new functions and variables and all that kind of stuff. And it's just inside that scope. The parent scope won't see it as well, which is powerful. And the final bit that let blocks are really great for is null checks. Remember earlier we had the variable name with the question mark after it. This is basically saying only do this let block if outfit1 is not null. So again, really, really powerful. And then you can just do a bunch of lines of code if the variable is not null. It's like doing a basically if not null check before doing a bunch of things. And the last one down here, the Elvis operator, affectionately known, because this is it here that I'm circling here. It's a question mark and a colon, and if you rotate it by 90 degrees, it kind of looks like Elvis Presley's little quiff and eyes. That's why it's called the Elvis thing. And it's really simple, really powerful. An Elvis operator takes two sides, a left and a right. So here's its left side, and here's its right side. And it basically says, hey, left side, are you null? Are you going to resolve to null now, left side? And if it does, if the left side is null, it will take its like backup option of the right side. However, if the left side obviously isn't null, it will take the left side. So it's just a nice way to sort of a quick toggle switching kind of thing. Yes, those were words. Here we go. And the last one on the feature slide. Am I all right for time? Because I'm sort of done with the features now. I'm just wrapping it up. Is that?
Yeah, we wrap this up and then we'll just discuss the sort of Java to Kotlin migration. I know you mentioned that earlier, and then we'll run on to people's questions. We've got a few coming in.
Awesome. So this is the last slide of the features. The point that I'm trying to make here is there are so many more features. Me personally, I'm discovering them daily, like using Kotlin, just discovering more things. There's more scoped functions. Just an example, like the let block. There's other things that are similar, like the also block, the apply block, the with, the run. And they just have different contexts. They have different references of themselves. They return different things. There's these ranges that we briefly covered, which let you count for, which basically let you give a bunch of numbers in a certain range. And they're really powerful. You can do like stepping up and stepping down in certain iterations. So for example, this middle line will loop from 8 down to 1. And it's really nice English as well. It's really readable, easy to read. So 8 down to 1 in steps of 2. So it will go 8, 6, 4. And this top one, 0 until 100 in steps of 10. So 0, 10, 20, so on. Ranges are really great. And of course, Lambda expressions, higher order functions, blah, blah, blah. The list goes on. Kotlin is incredibly powerful, and there's far much more than I've covered in this slides, in these slides. But yeah, that's just a brief overview of some of the big dog features.
I'm sure you could have gone on for a while there, Ben. So just out of interest then, have you ever had any bad null experiences personally that you'd want to share online? Yeah,
so nothing sort of that obviously sticks out in terms of an actual story, but in the years before we switched over to Kotlin at the very group, we definitely had a couple of uncaught null pointer exceptions that brought the app to a screeching halt. But obviously sort of react to those as quickly as possible. And the moment that we could sort of jump ship to Kotlin, our migration was relatively quite quick, to be honest, but also phased as well. But yeah, the moment that we could, and we get all that sweet null safety for free, that's really, really powerful.
Cool. Well, yeah, I guess that brings us on to our next point then. It's something that you showed me, I think, late last week, which I found incredible in terms of the actual migration from Java to Kotlin and just how easy it is. I couldn't believe it, to be honest. So, yeah, can you give us an example of that? I'm sure, yeah. I know you've got something prepared for that.
Yeah, indeed. What I want to say before I share the slide is if you're a Java developer thinking about this, pop your seatbelt on because you might get blown out your seat at this moment. Here is a slide migrating from Java to Kotlin, okay? And I'm talking specifically if you're using IntelliJ or if you're using Android Studio. They give you something for free, which is this, which is mad. imagine I have this Java file called animal.java. What I can do is I can right-click on that file inside of either of these IDEs, and just one of the options is called convert Java file to Kotlin file. I do not make this up. Check IntelliJ, check Android Studio. You click that option, you just click it, and you're done. And what it will do behind the scenes, it will do some magic, and it will turn this massive Java file into its Kotlin alternative, which is amazing. You can just click a button and it will convert it for you, which is really great as well, because if you're sort of doing it at the same time as learning Kotlin, you can sort of take a bunch of Java code and convert it and see what the actual Kotlin alternative is. And that's a really nice way to learn, by taking your already understood context and just sort of tweaking it, which is really, really powerful. And obviously you can do this bit by bit when you're migrating, because Kotlin and Java work beautifully together, right? So you can do this bit by bit. You can phase some files over, leave some files, reduce the risk. And there's even this other little bit as well, if that wasn't already enough, there's this bit. If you've got a Kotlin file already, right, you've written a Kotlin file, and you paste into that file Java code, right? You're pasting Java code into a Kotlin file. The IDEs, again, IntelliJ and Android Studio, will go, hang on a minute, hold up. You're pasting in Java code now. Do you want me to convert that to Kotlin for you right now? I'll do it for free. And if you click yes, again, it's done. It's absolutely done. And it will convert that Java code into its Kotlin alternative. Again, great for learning, because you can sort of take snippets of Java and convert it to Kotlin and just be like, oh, right, that's how that's supposed to look in Kotlin, which is really great. And obviously, as I said before, they work interoperably, so there is no excuse not to even just, to consider migrating at this point. And as we know, Kotlin can be used anywhere that Java can. So what are you waiting for is the point.
Yeah, that's incredible. It's amazing to see just how easy that is. Yeah, it completely shocks me, to be honest. So yeah, I mean, just in terms of just cautious of time now, I want to get around to a few questions. So you mentioned earlier that you wanted to show some places where you can go in terms of learning, resources for learning.
Yeah, let me just
look it up. Apart from obviously doing the obvious, migrate to Kotlin.
Yeah. So there's some really great places to learn. I'm just pointing out a few. So in the top right, there's that GitHub link that I showed you to where the actual Kotlin source code is, in case you wanted to go and look at it, wanted to go and contribute to it, if you wanted to raise an issue and so on. It's very, very active, which is really great. The two top ones of these speech bubbles then are ones that I would like to point out. I like to learn with videos. Obviously I've got my YouTube channel. I try and give back a little bit. But I really like learning via videos and sort of seeing someone explain it. So if you're like that, then I'd like to recommend this top left one, a channel called Coding and Flow. This guy is incredible. Most of the time he does like really detailed Android tips, but he has one playlist that's called Kotlin Course for Beginners and Java Devs that's focused just on Kotlin. There's a bit.ly link to it as well if anyone wants to sort of quickly type that down. I don't know, or I can probably get it to you some other way to actually access that course. And he's got loads of videos there. It's brilliant. In the top right, Free Code Camp, they have this one video now, not a playlist, called Kotlin Tutorial for Beginners. It's about 2 or 3 hours long, but it is literally Kotlin for beginners all the way up. And it's really, really great, really nicely explained. If you're not somebody that enjoys learning via videos, then this bottom left one, Tutorials Point, is a website that do loads of different programming language tutorials points. But their Kotlin one is really, really nice, really good. And it, again, starts you from the ground up, building all the way up. And the final one, and this is the bit that's actually mad, the Kotlin Lang website itself, so the Kotlin Lang official website, has this play.kotlinlang.org, which gives you, in the web browser, an interactive, real coding environment. You can code Kotlin in that website and hit play in that website and see the Kotlin code running and what it does, which is amazing, because you can sort of go and try out little snippets. But then combined with the next bit down, which is their tutorials link, they do step-by-step learning of the Kotlin language and also give you that playground feature. So you can learn something, mess around with it, learn something, mess around with it, and pass challenges as well, which is really, really powerful. So all these are really, really great recommendations for actually getting started with Kotlin, if hopefully some of what I've said has inspired you or interested you.
Yeah, that's really cool. I'm sure it definitely has done. We'll make sure that we get all these links, by the way, sent out to everyone, including you can watch this back if you want, or if you joined us halfway through, you can watch all this back. And yeah, we'll get these links sent out to you, as well as links to Ben's YouTube as well, which I mentioned earlier. pretty funny, as you could probably imagine. So yes, let's get on to some questions now then, Ben. I'll just bring us both back up.
Cool.
We've had a few come in. We've had some guys been pretty active on the comments bar on the side. I'm not too sure if you've been keeping an eye on that, Ben, but some of the questions have sort of been answered between themselves, but I'll put a few to you anyway.
Okay.
So first one in from Maharaj or Jazvir, sorry. Can you please explain mobile cross-platform, please? I guess it's quite a lower level.
Sure. So in terms of actually explaining it in more detail, I've not actually used it myself. It was more of research of the idea, but I can explain the sort of concept behind it briefly. You write one Kotlin code base, maybe multiple files, whatever it is, and then you use the Kotlin multi-platform tool. I'm not entirely sure where that sits. I've got to be honest, if it's inside of the IDE, if it's something else that you need to install. And then it will build out the .framework files or zip or folder, whatever it is for iOS projects, for iPhone projects, and it will also build out the .jar zip file for Android-based projects. Yeah, unfortunately, I haven't had much of a play with it myself, but it sounds incredible. Like, all of these Flutters of the world and all of these like React natives that promise one code base will build both apps. That's historically been a very difficult thing to do. But this one, it seems like a really nice solution, really streamlined.
Yeah, okay. I mean, that's sort of covers. Jazvir again asked what tool is used for iOS development using Kotlin. I guess that's.
Yeah, I wouldn't know, to be honest. I assume you're going to be using IntelliJ, but they've probably got an Xcode plugin as well. So Xcode is the IDE that iOS developers use. I'm sure they've probably got an Xcode plugin for that. Could be wrong.
Okay. Yeah, cool. So let's have a look what else we've got here. Is it possible to use vast amounts of Java frameworks? Is it possible to call into Java classes from Kotlin classes? Great question.
Yes. Most of the so we obviously in our app we've now 100% Kotlin, which is really nice.
Yeah.
We call back because obviously a lot of the Android classes and components, they're all still in Java. So calling back to them is literally as easy as just calling the function. They're completely interoperable. So yeah, because a lot of the things like just one that comes to mind, the date class, right, is a Java class that we still use as a Java class, but we refer to it all the time in Kotlin. We just call it like it's Kotlin. It's incredibly interoperable. I hope that answers the question. It's basically me just going, yes.
Yeah. No, I think it's it's a fairly standard answer. Cool. We've got one from LinkedIn here. Can you guys share any ramp up plan to get into Kotlin? I guess what they're asking there is, what your thoughts in terms of getting into Kotlin, which you've just showed on that slide before.
Yeah, sure. There's something probably I'll tag on to the end of that, actually. So obviously getting a nice base understanding of Kotlin is great. And I showed you the migration thing where you can convert on the fly. One of the nice things that we did when we were doing the Java to Kotlin conversion is we used a tool called Clock, C-L-O-C, which is a GitHub tool. And it runs in the terminal. And it basically goes to your project and it counts the lines of code of a specific language. So we got a little table that said, oh yeah, Java, 100%. And then as we were doing it, we kept clocking in as we were doing our phase transition until it got to 100%. And it also, obviously, as I said, it counts lines of code. And I think, I can't be quoted here because I can't remember the exact number, but it was either 35 or 40% literal drop in lines of code from, having Java. When we've done the full conversion, like a 35% drop in code. And obviously that's really important when you're building an APK or if you're storing obviously your code solution in like a Git repository as well. Really, really powerful stuff.
Yeah, that's huge amount of difference. So another question here. Nulls in Kotlin implies pass by reference. Static types would prohibit recasting. Is that the case? Can you see these questions, Ben? Because I might be reading these completely wrong.
Where is that?
If you click on the ask a question tab down at the bottom. Can you see that?
Oh yeah, nulls in Kotlin implies pass by reference. Static types would prohibit recasting? Is this the case? I believe so, yes. To give a short answer to that.
Yeah, okay, cool. No worries. I didn't know if I was reading it out correctly or not. So
sorry.
Jasvir again, I think he was actually answering a point that you made earlier, Ben, during the presentation. He's put, yes, it's easy to convert. I think it was his in terms of the actual migration from Java to Kotlin. He said, yes, it's easy to convert by using that option, but while converting very big classes, there are certain issues, especially when you use lots of Java-related code. What can be the best option for that? Is it like I think you actually mentioned that it's best to do, file by file rather than one huge amount, just to save any sort of mistakes.
Sure, yeah. I think I understand what he's getting at here. It's as agreed, yeah. It's better to do smaller chunks and then sort of reflect on that and check that it's sort of done the right thing. I will be honest, when we first did, this was 2 years ago or something now, 2 or 3 years ago when we did our conversion, the convert to Kotlin option was still quite new and there was a lot of bugs in it. So when we hit it, obviously it would do the majority of it, but it would add like little flavors and stuff in that were just completely weird and useless. Now it is much better. I can say that with my hand on my heart, but yeah, it still isn't perfect and there'll still be like little quirks and stuff. And unfortunately, my sort of advice for those moments is often the IDE itself will pop up a little like yellow light bulb and it'll sort of like try and help you refactor that code. It'll be like, oh, you didn't need this, why have you written that? Which is nice. So that's sort of the first step. There'll often be like a red light bulb if there's errors to help you, automatically fix those errors as well. But yeah, unfortunately, if you pass both of those sort of obstacles and you still got some like weird output, then unfortunately it's about trying to understand what it was converting and how it went completely wrong. It's not a perfect tool, but it's much better than it used to be.
Okay, cool. I think one more question then, Ben, from me, is there anything that Java has that Kotlin doesn't in terms of benefits, pros, if anything?
Yes. If it's all right, I do have a slide just sort of encapsulating that information, if that's useful to you.
Yeah, go on then, bring it up. I can get it on my screen.
Okay, cool. It's just one little slide. Oh, right, yeah, I've got to share the thing, haven't I? Sorry.
Yeah, we'll finish with a slide. Why not?
Cool. So, yes, in short, there are some things that Java has that Kotlin doesn't. There isn't a big list. It's not massive. And in fact, 90% of the things on this list, Java has an alternative to, or like a different syntax to, or the fact that it's removed makes sense for the Kotlin language. But the one that I will point out that even I'm upset about is this top one, the ternary operator, which in Java is incredible. It's just like it's a expression. Check if thing is true. Question mark, if it's true, do that thing. If it's not true, do that other thing. That's something that exists in Java and does not exist in Kotlin. And the forums are livid about this, but there is a close alternative to it. It's not a ternary operator, but it's close enough. And it's this like single line if statement. Same thing. Again, it's dealing with the expression. If it's true, do this, else do this. It's not a ternary operator, but it's close enough. And that's the one thing that is, wars have been fought over. Other than that, though, there's a little list down here of all of the ones that are sort of really relevant. Statics in Java. Java has like the static keyword. Kotlin has the object keyword for like true singleton patterns. And it has like the companion object block here. So inside of a class, if you wanted to add static bits to it, you just put all of your, in quotations, static things inside of the companion object. And it will achieve the same results as static. So again, an alternative. And Kotlin, in the bottom left here, Kotlin doesn't actually have like primitives as we sort of know in Java. It doesn't have like the lowercase I int. The int that we use in Kotlin is actually a class. So there's just another little thing. And there's a couple other things in this list: checked exceptions, non-private field, wildcard types. There's a couple of things, but really most of them are things that you can move very easily past or not even need to consider in the first place.
Cool. Excellent. I think that's all we've got time for, Ben. But I think in summary, just migrate over to Kotlin, yeah?
Yeah, there you go. Migrate over to Kotlin. And let us know how your migration went. And if you've got any questions for me or anything in particular, my details were all at the bottom of those slides, so feel free to reach out to me.
Yeah, and we'll make sure we send out all Ben's contact details on various different platforms, and links to this to watch this back as well. So yeah, thank you very much, Ben, for joining us today. I thought that was really good, really insightful and fun, and great slides as well.
Thanks.
So yeah, keep an eye on our meetup page, Orbis Connect. You can follow us for future episodes, future events that we do. And yeah, stay safe, everyone. Ben, thank you again. And
thanks so much, Joe.
see you soon, mate.
Cool. See you, mate. Bye, everyone.